Today we're talking about 8th grade, Chapter 6, Lesson 1, Solve two-step equations. A two-step equation has two different operations. And it looks similar to this one in the box. 3x plus 5 equals 20. So in this equation, there's multiplying, because it's 3 times x, and there's also addition, plus the 5. So this part that's on the left before the equal sign is the expression. And if we're talking about the whole thing, from the 3x all the way to the 20, that is called the equation. And each part of that has terms. So the 3x is a term, and the 5 is a term. In the 3x term, the 3 is called the coefficient. The x is the variable. And the 5, he's all there by himself, is called the constant. To solve a two-step equation, or to solve any equation, we use inverse operations. Inverse just means opposite, because opposite operations undo each other. So, for example, addition undoes subtraction, and subtraction undoes addition, because they are opposite. And then there's multiplication and division. Those are opposites. And the new one is squares. Square and square root are opposites. So those are opposites, and they undo each other. When solving an equation, what we want to do is get the variable by itself. To really get to know a variable, you must get it alone. Think about that. If you want to get to know somebody, you want to get them by themselves. So that's what we're going to be doing with the equations, is getting the variable by itself. Please make sure that you show all the steps when you're solving, and don't just try to skip something. This is building the base for algebra, and we need to make sure that we're doing this correctly. So for example 1, we're going to solve 3x plus 10 equals 1. So you kind of think about PEMDAS, the order of operations, but we're undoing stuff. So we're going to be doing stuff backwards. So usually we save addition and subtraction to the end, but since we're doing it backwards, we're going to be doing it first. So 3x plus 10 equals 1. So what we want to undo first is the addition. And the opposite of adding 10 is subtracting 10. And if you do something to one side, you have to do it to the other. We have to stay fair. So think of this equal sign as a great divide, a border, a wall. You must do it on both sides to stay balanced. It says over here, always be fair. Always be fair. If you do it to one side, you got to do it to the other. Kind of like, let your OCD fly. You've got to keep it balanced. If you do it to one side, you must do it to the other. You also must keep that equal sign right there in the middle. He cannot float around. He stays right there. Okay, so if we subtract 10 from the left side, 10 minus 10 makes 0, so that's canceled. It's gone. And all that's left is the 3x equals, and on the other side, 1 minus 10 makes negative 9. The x is still not alone, so I'm looking at just the side with the x. And right now they are multiplying by 3. So the opposite of multiplying by 3 is dividing by 3. We want to divide both sides by 3. When I do that, 3 divided by 3 makes 1. And 1x is just the same as x. On the right side, we have negative 9 divided by 3. And negative 9 divided by 3 is negative 3. So now the x is alone and we know its value. Next example, solve n divided by 2 minus 9 equals negative 5. So that's n divided by 2 minus 9 equals negative 5. Again, remember you want to keep that straight, and remember that whatever you do on the left, you have to do on the right. So the first thing we want to undo is the adding or subtracting. So this time we're subtracting 9. The opposite would be to add 9. So on the left, when we add 9, those are opposites, so they cancel. And all that's left is n divided by 2. And on the right side, we have negative 5 plus 9. So those have different signs. We're going to subtract. So 9 minus 5 makes 4. And we take the sign of the larger, which is positive, so it's positive 4. Now we do the opposite of dividing, which is multiplying. So I'm going to multiply by 2 on both sides. And if it helps, you can put the 1 underneath there and think about how you are simplifying the 2's. If you do that, then all that's left is the n. On the other side, we have 4 times 2, which is 8. So n equals 8. Now, the problems that you're going to be solving on your worksheet aren't word problems, but I did want you to see what some of the word problems that would go with similar equations. So this one, for example, Christian drives the same distance Monday through Friday, commuting to work. Last week, Christian drove 25 miles on the weekend, for a total of 60 miles for the week. Okay, so the total was the equal part. And he drove Monday through Friday. That's 5 days. So 5 times something. And then another 25 on just the weekend. That's where they got that equation. So this is 5x plus 25 equals 60. And we're going to solve for x. So first we undo the addition. So we subtract 25 on both sides. When we do that, those cancel and 5x is by himself. And on the other side, 60 minus 25 is 35. And then we're just left with 5 times x, and we want to do the opposite, which would be divide by 5. 5 divided by 5 would make just 1, and 1x is just x. And 35 divided by 5 is 7. It is very important that when you're working these equations, it looks like this. Notice how it goes straight down. I did the same thing to each side. I kept my equal sign in the middle. Please be sure that you're doing that. Let's look at some of the problems you're going to be working. So I'm going to look at number 3. And the variables on the right side, we still work the same way, even if it's on the right side. So we look for addition and subtraction. I see minus 2. So the opposite of minus 2 is plus 2. And 13 plus 2 makes 15, equal sign straight down. And negative 2 and a positive 2 make 0, so they're canceled. And the 5m is by himself. All that's left is multiplication, and the opposite of multiplication is division. So we're dividing by 5 on both sides. 15 divided by 5 makes 3. And on this side, the 5's cancel, and m is by himself. Okay, and number 6. This one looks a little bit different too. Okay, so I see that we are subtracting 16, but that's a positive 16. So if I add a positive 16 to a positive 16, I'm not going to be getting rid of the 16. I'd be making 32. I don't want to make 32. I want to get rid of the 16. So I need to do the opposite of 16, which is negative 16. So negative 16. Those are opposites. They cancel. And what comes down is negative r divided by 7. And on the other side, I have 21 minus 16, which makes 5. Okay, now we want to get rid of that negative r divided by negative 7. That negative sign can go with either the r or the 7. It's just minus. So let's go ahead and get rid of that. The opposite of dividing by 7 would be multiplying by 7. And I want to get rid of this sign too, so I made it negative 7. And negative 7 divided by negative 7, well, do it like that. Those would cancel. So r would be by himself. And then on the other side, we're multiplying by negative 7. So 5 times negative 7 makes negative 35. So if there is a negative sign in front of something that looks like a fraction, make sure that you use that with the number that you're trying to get rid of, like the negative 7 there. Okay, let's look at number 8, which also looks a tad bit different. We have division and we have adding. We can't really get rid of the adding 5 yet because this is kind of like you have to do that first. If we were working the problem, we'd have to do what's on top first before we divide it by 7. So since we're going in reverse, we have to get rid of the 7 first. So the opposite of dividing by 7 is multiplying by 7. So I multiply by 7 on both sides, which makes that cancel. And all that's left is the z plus 5 equals negative 21. Then we can get rid of the plus 5. And those cancel. So all that's left on the left is z. And negative 21 plus negative 5 makes negative 26. Okay, let's also look at number 5. So we have negative 1/3 times y minus 6 equals negative 11. So first we want to do the opposite of minus 6. That would be plus 6 or positive 6, whichever one. And since those are opposites, they cancel. And we have negative 1/3 times y equals negative 5. Now we have negative 1/3 times y. So we know the opposite of multiplying would be to divide. And how do we divide by fractions? We have to do keep, change, flip. So we have to take the reciprocal of that fraction and multiply. So the reciprocal would be -3/1. And you have to do it on both sides. Of course, the -3's cancel, the 1's cancel, and y is by himself. And then on the other side, -5 times -3 makes 15/1, which is just 15.